Hi everyone, welcome to Unit 15 of online course on probability distributions. So far, we have discussed random variables, different types of random variables, namely discrete random variable, continuous random variable, and its probability distribution functions and general concepts behind the distribution function. After that, we discussed some important discrete distributions, that is, probability distributions of discrete random variables. And namely, we have discussed discrete uniform distribution, we have introduced Bernoulli distribution, we have considered binomial distribution, and then we have introduced the Poisson distribution. Corresponding to each of these distributions, we have derived some important properties of distributions and identified its mean, variance, moment generative function, and some other characterization properties. Now, in this session, what we are going to do here is we are considering some numerical examples, that is, some practical problems. And that problems are addressed on the basis of different probability distributions, especially binomial distribution and Poisson distribution. So, in order to find probability values corresponding to some problems, we are considering binomial distribution or we are considering Poisson distribution, and that type of problems are discussed in the next modules. So, here I am introducing some problems, numerical examples related with the binomial distribution. First of all, let us consider one problem that is a very simple problem and a usual problem related with the binomial distribution. Suppose we are tossing a coin, an unbiased coin, some number of times, say 8. And the question here is, what is the probability of getting some events? And here the first event is less than 4 heads, more than 5 heads, like that events. We can add some more events here and also we can find the probabilities. Suppose we have the problem like this, that is, an unbiased coin is tossed a number of times and we are finding the probability of getting certain events. How we will do this problem? Especially here this problem is, it is a coin tossing experiment. So, coin tossing experiment, as we know, there are two outcomes, head and tail, and probability of getting head or probability of getting tail is constant throughout the trials. So, here suppose we have, suppose you consider x a random variable, that is our number of heads obtained suppose x is a random variable that is defined as number of heads obtained when a coin is tossed 8 times here. So, n is equal to 8. And of course, P is the probability of getting success. Probability of getting success, here our success is our getting head. So, P is equal to, for a coin tossing experiment, we know the probability of getting head is equal to 1 by 2. Also, probability of getting tail is also 1 by 2. So, P is equal to 1 by 2 and Q is equal to 1 by 2. So, here x is a random variable, that is a binomial with parameters n and p, where n is equal to 8 and p is equal to 1 by 2. If it is, we have the probability mass function, that is probability of x is equal to x, that is equal to ncx p power x q power n minus x, where x is a 0, 1, 2 up to n, and p and q are satisfying this equation, p plus q is equal to 1. So, this is the probability mass function of the random variable x. Now, come to the point. What is our problem? Here the problem is, what is the probability of getting, first event is less than 4 heads. So, less than 4 heads, probability of getting less than 4 heads, probability of getting less than 4 heads. So, this is the problem we are problem, that is, we have to find the value of probability of getting less than 4 heads. That is, this is same as probability of the random variable x is number of heads. So, x is less than 4. So, our aim is to find the probability of x less than 4, and that is equal to probability of x is less than 4 means what? X can have the value either 0 or 1 or 2 or 3. These are the possible values when x less than 4, and this probability is equal to what? Probability of x is equal to 0 plus probability of x is equal to 1, probability of x is equal to 2 plus probability of x is equal to 3. So, in order to find probability of x less than 4, we are finding probability of x is equal to 0, probability of x is equal to 1, probability of x is equal to 2, and probability of x is equal to 3. And using the binomial probability mass function, this value already we have the value of probability of x is equal to x, we have 8cx p power x, p is here 1 by 2 power x, and q is also 1 by 2 power 8 minus x, or we can write this value as 8cx, because p and q are equal, this can be written as, this is the value. So, probability of x is equal to x for the corresponding to our problem is 8cx 1 divided by 2 power 8. So, this is equal to what? Probability of x is equal to 0. What is the value of probability of x is equal to 0? That is 8c0 1 by 2 power 8. So, this value is 1 by 2 power 8 plus probability of x is equal to 1, that is 8c1, 8c0, you know 8c0 is 1, that is why we are right. 8c0 1 by 2 power 8, 8c1 1 by 2 power 8, 8c2 1 by 2 power 8, and finally 8c3 1 by 2 power 8. And simplifying this, this is 1 by 2 power 8 is common to all factors. So, 1 by 2 power 8, this is 1, this is 8c1 is 8, 8c2 is 28, and 8c3, that is 8 into 7 into 6 divided by 3 factorial, that is 56. See, you can, you know, ncx, simplify, this value is actually n factorial divided by n minus x factorial x factorial. Using this, we have the value of 8C0 is 1, 8C1 is 8, 8C2 is 28 and 8C3 56. So, this is the value of this probability of getting less than 4 heads, that is 93 1 into 1 by 2 power 8. So, this is the probability of x less than 4, that is probability of getting the event less than 4 heads when we are tossing a coin 8 times is equal to 93 into 1 by 2 power 8. So, this is the way we are calculating probability values corresponding to the problems like this using the binomial distribution. Again, one more, we have another event, the question is, what is the probability of getting more than 5 heads? See, what is the probability of getting more than 5 heads? So, suppose we are finding probability of getting more than 5 heads. Probability of getting more than 5 heads. So, here also we transform this as x greater than 5. We have defined the random variable x as the number of heads. So, probability of getting more than 5 heads is probability of x greater than 5. What is the meaning of probability of x greater than 5? That is probability of either x is equal to 6 or 7 or 8. We are tossing the coin 8 times. So, maximum is 8. And this is equal to probability of x is equal to 6 plus probability of x is equal to 7 plus probability of x is equal to 8. And simplifying this expression, again you note probability of x is equal to x, we have value is 8cx 1 by 2 power 8. This is the value we have. So, corresponding to that, you substitute the value of x as 6. So, this is 8c6 1 by 2 power 8 plus 8c7 1 by 2 power 8 plus 8c8 1 by 2 power 8. And that is equal to, simplify this expression, 8c6, that is equal to again 28 plus 8c7, that is 8 plus 8c8, that is 1 by 2 power 8. That is 37 into 1 by 2 power 8. So, probability of getting more than 5 heads is equal to 37 into 1 by 2 power 8. So, this is a very simple example of a practical situation where we are applying binomial distribution. Now, another example, suppose you are considering another example. The question is, a student takes a 10 question true false quiz. So, the question is either it is true or false, but not study and randomly guesses each answer by the student. Find the probability that the student passes the quiz with a grade of at least 70% of the question correct. So, the problem is, here also this is a practical situation where we can apply binomial distribution. Why we are applying the binomial distribution? Because you can consider this is an experiment, or a student takes a 10 question true or false quiz. So, the question, the outcome of the question is either success or failure, or that is true or false, and they are equally likely. So this is, suppose P is the probability of getting a true answer, the probability of answering this true, that is 1 by 2, and here Q is also 1 by 2. And and the student takes 10 questions. So how many questions are there? N is equal to 10. And the question is, find the probability that the student passes the quiz with a grade of at least 70% of the questions correct. So the question, suppose you are defining X as number of correct answers. So suppose a student is answering the questions and X is the number of correct answers, and how many questions, total questions are there? 10. And what is the probability of getting a correct answer? That is 1 by 2. Here also you note Q is also 1 by 2. And what is the problem? The problem is the student, the problem is here, you can see the problem is find the probability that the student passes the quiz with a grade of at least 70% of the questions correct. At least 70% of the questions correct means X is 70% means total 10 questions. So at least that means 7, greater or equal to 7. At least 70% of the questions correct. That means 7 questions, 8 questions, 9 questions, or all questions are correct. So what is the probability of X greater or equal to 7? That is probability of X is equal to 7, 8, 9 and 10. So similar to the earlier problem, this is equal to probability of X is equal to 7 plus probability of X is equal to 8 plus probability of X is equal to 9 plus probability of X is equal to 10. So this is the probability of X greater or equal to 7. Remember, our probability mass function corresponding to this is probability of X is equal to X is here NCX, that is 10 CX, and P, that is 1 by 2 power X, and Q, that is also 1 by 2 power 10 minus X, that is 10 CX 1 by 2 power, again both are combined, you have this value. So just to substitute this value here, this is 1 by 2 power 10 is common to all the expressions, and then this is 10 C7 plus 10 C8 plus 10 C9 plus 10 C10. So probability of X greater or equal to 7 is equal to 1 by 2 power 10 into this expression 10 C7, we know 10 C7 you can find, 10 C8, 10 C9, 10 C10. And substituting that values, this is the probability. So here the problem, what is the, find the probability that the student passes the quiz with a grade of at least 70% of the questions correct, that is given by this expression. So another example, this is a question related with something in the industrial field or in the market field. Suppose a manufacturer knows that from the previous experience, a manufacturer knows that 5% of his products are defective. when the manufacturing certain product, that manufacturer knows from his previous experience that 5% of his products are defective. If the products are sold in boxes of 10 and guarantees that not more than 2 will be defective, what is the probability that a box will fail to meet the guaranteed quality? So this is a problem. Here the problem is you are required to find the probability that a particular box will fail to meet the guaranteed quality. What is the guaranteed quality? The guaranteed quality is not more than 2 will be defective. The box containing 10 products, of which not more than 2 will be defective. That is the guaranteed quality of the manufacturer. So the question is to find the probability that a particular box will fail to meet the guaranteed quality. Here you look, this is a problem, and this problem can be modeled using binomial distribution. Why? Because there are two options. That is, the product may be defective or non-defective. Product may be defective or non-defective. And the probability of getting a defective, that is, suppose we have denoted by that P, from the previous experience, 5% of his product will be defective. So that means P is equal to 0.05, 5%, 5 divided by 100. You can write either 5 divided by 100 or 0.05. And what is the probability of getting a failure, non-defective? That is 1 minus P, that is equal to 0.95. And a box consists of how many products? 10 products. So you are given N is equal to 10. So the question, a manufacturer knows that 5% of his products are defective, and if the products are sold in a box of 10 and guarantees that not more than 2 will be defective, what is the probability? That is a question. So here, look, here this problem can be modeled using the binomial distribution. Suppose X is the number of defectives. Suppose we are defining the random variable X as the number of defective. X is number of defective. Then X is a binomial random variable with the parameters N and P. Okay. And here N is equal to 10. You are given N is equal to 10. And P is equal to 0.05. These are given to you. And the question is, what is the probability that a particular box will fail to meet the guaranteed quality? What is the quality guaranteed by the manufacturer? Not more than 2 will be defective. Not more than 2 will be defective. So a box will fail to meet the guarantee. Quality means the number of defectives is larger than 2. So probability of fail to meet the guarantee of the manufacturer, that is, you are making that statement in terms of random variable, that is equal to probability that X greater than 2. X greater than 2, probability of X greater than 2 means we can write this is 1 minus probability of X less than or equal to 2 by taking the complement part. So 1 minus probability of X less than or equal to. So that is, and it's just look here, this probability of X is equal to X for this binomial random variable, we can write this is 10C X, N is equal to 10 here, P is equal to 0.05, so 0.05 power X and 0.95 power 10 minus X. So this is our probability mass function. Probability of x is equal to x is 10 cx p power x, that is 0.05 power x, q power n minus x, that is 0.95 power 10 minus x. So that using that expression, we can find this value 1 minus probability of x less than or equal to 2 means, actually this is 1 minus probability of x less than or equal to 2 means x is equal to either 0 or 1 or 2. So these are the three possibilities of x less than or equal to 2. So substituting, this is 1 minus probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. Substituted the values, this is equal to 1 minus probability of x is equal to 0, that is 10C0 0.05 power x, that is 0, 0.95 power 10 minus x, that is 0, 10 minus 0. So this is actually 0.95 power 10. Probability of x is equal to 0 is obtained as 0.95 power 10. Probability of x is equal to 1, that is 10C1, that is 10 itself, 0.05 power 1, 0.95 power 9 plus 10C2, that is 10C2 is 45, 0.05 power 2, 0.95 power 8. So probability of x greater than 2 is the simplified value of this expression. So we can have the probability that actually the manufacturer is claiming that not more than 2 will be defective in a box consisting of 10 products, and that guaranteed quality is failed when the number of defectives is larger than 2, that is probability of x greater than 2, and that value is obtained as this simplified expression of this quantity, and that is obtained using the binomial distribution, binomial probability mass function. So this is an example where we can apply the binomial distribution to find the probabilities, like the probabilities of events like this. And this is another example. Suppose a certain brand of seeds is sold in bags of 15. The typical proportion of orange seeds in these bags is 1 in 3. Find the probability that in a random bag of these seeds, there will be the events like this. The first event is exactly 5 orange seeds. Second event is more than 12 orange seeds. And third event is at least 2 orange seeds. Similar events, suppose we are defining events similar to this one, here there also we can find the probabilities. So this is also an example of applying the binomial distribution. Why? Because we have a bag consisting of 15 items, and the proportion of a certain attribute, that is orange seeds, is given to you. So we have two situations there, that is either orange or not orange, non-orange seeds. So, and the number of seeds given to you is, 15. And proportion of orange seeds, that is the success, is 1 in 3, that 1 out of 3. So P is equal to 1 by 3 is given to you. Of course, the Q, that is probability of getting of a non-orange seed, is 1 minus 1 by 3, that is 2 by 3. So this is given to you. And suppose X is the number of orange seeds we have. Number of orange seeds we obtained. Then X is actually a binomial random variable with parameters n and p, where n is equal to 15 and p is equal to 1 by 3. And hence, the probability mass function we can write, probability of X is equal to X, that is 15Cx, p power x, that is 1 by 3 power x, q power, that is 2 by 3 power 15 minus x, where x have the values 0, 1, 2 up to 15. So, for this particular problem, we have the probability of X is equal to X is 15Cx, 1 by 3 power x, 2 by 3 power 15 minus x. Now, just look what are the problems we have. Find the probability that in a random bag of these seeds, there will be exactly 5 orange seeds. So, exactly 5 orange seeds is, we have probability of X is equal to 5. So, exactly 5 orange seeds is 15Cx, here it is 5. P power x, that is 1 by 3 power 5. Q power, that is 2 by 3 power 15 minus 5, that is 10. So, this is our probability of getting exactly 5 orange seeds. See what is another event you are given, that is more than 12 orange seeds. What is the probability of getting more than 12 orange seeds? So, how it is obtained? More than 12 orange seeds, that is probability of X greater than 12. So, only thing is that you convert the statement in terms of the random variable. Here the random variable X is the number of orange seeds, and the question is, what is the probability of getting more than 12 orange seeds? That means we have to convert that statement to probability statement as probability of getting X greater than 12. And X greater than 12, you know, this is probability of X is equal to 13, 14 or 15. That is probability of X is equal to 13 plus probability of X is equal to 14 plus probability of X is equal to 15. And substituting the values, you will have the this 15C 13, 1 by 3 power 13, 2 by 3 power 2, again 15C 14, 1 by 3 power 14, 2 by 3 plus 15C 15, that is 1, this is 1, 1 by 3 power 15 and 2 by 3 power 0. So, this is the probability of X greater than 12. Probability of X greater than 12 means probability of getting more than 12 orange seeds. And the next problem is to find the probability of at least 2 orange seeds. At least 2 orange seeds means probability of at least 2 orange seeds. That is, here it is probability of X greater than or equal to 2. That is 1 minus probability of X less than 2. That is 1 minus probability of X is equal to either 0 or X is equal to 1. Substitute the values, we have 1 minus 15 Z0 P power 0, that is 1 by 3 power 0, that is 1 by 3, that is 1, okay, and 2 by 3 power 15. Actually, this is 1, and this is 15C1 1 by 3 into 2 by 3 power 14. So this is our probability of getting at least 2 orange seeds. Another question in an industrial field you can have that the large lot of electrical fuses is supposed to contain only 5% defectives. If 20 fuses are randomly sampled from this lot, find the probability that at least 2 defectives will be observed. Here also the problem is similar, just I'll give the idea of how we are work out. Here the large lot of electrical fuses is supposed to contain 5% defectives, so P is the probability of getting defectives, so 5% 0.05, and the 20 fuses are randomly sampled, so n is equal to 20. Okay, and suppose x is the number of defective fuses, and so this x follows binomial with n and p. So probability of x is equal to x, we can write that's NCX, that is 20CX, 0.05 power x, 0.95 power 20 minus x, where x is equal to 0, 1, 2, etc. up to 20. So that is the probability mass function. From this you can find whatever be the probability required to find regarding the events. So here it is at least 2 defectives. So you find probability of x greater than or equal to. And in addition to that, another question here is find the mean and standard deviation. How do you find the mean and standard deviation of this particular problem? It is, say, mean is equal to expectation of x. Since x is a binomial random variable, we have already given that x is a binomial random variable with n is equal to 20 and p is equal to 0.05. So expectation of x, that is our mean is equal to expectation of x, that is by formula we have np, that is 20 into 0.05, and variance, that is equal to npq by the formula, that is 20 into 0.05 into 0.95. And suppose your question is about the standard deviation. What is the standard deviation of this particular random variable? That is square root of the variance, and that is square root of this expression, 20 into 0.05 into 0.95. So like this, we can find the standard deviation, we can find the variance, such quantities. So all these type of problems are the problems related with the binomial distribution, because these random experiments are the experiments having 2 outcomes represented as success and failure. So whatever be the probability required with regard to certain events, you can find using the binomial probability mass function. So we can do some more problems in addition to those problems. We can do some more problems in the next module. So with this, let me stop here. Thank you for hearing this session. Thank you.